Abhar Patera, can you hear me? Praveen, can you hear me?
Yes, ma'am.
Thank you. Good morning, all of you. So, we were dealing with boiling points of alcohols. Said ethanol. Ethanol. Its molar mass, molecular mass is 46. Molar mass 46 grams per mole. And corresponding molecular mass compound that is propane 44. Propane CH3 CH2. Propane with 44 molecular mass. This is heavier, but almost similar. 46 and 44 are almost similar. So both are almost equally heavy. On heating, both should go almost same temperature to the vapor phase. But its boiling point is 351 by 351 N, and its boiling point is 231. There is a vast difference between the boiling points. Why it is so? Because in alcohol there exists hydrogen bonds. All the alcohol molecules are interconnected, one after the other, all are interconnected. But such hydrogen bonding is not present in propane. So alcohols, you compare alcohols with comparable molecular mass other compounds, alcohols will be having very high boiling points. You compare different compounds, alcohols, aldehydes, ethers, hydrocarbons. Highest boiling point will be for alcohol because of the existence of hydrogen bonds among the. So write one question. Arrange the following according to increasing boiling. Arrange the following. Arrange the following according to their increasing boiling point. One is pendant 1 or pendant 1 or normal butane. Normal butane pendant then epoxy ethane. Epoxy ethane. One is alcohol, one is hydrocarbon, one is aldehyde, and the other one is epoxy ethane, that is C2H5. Epoxy ethane is angle. It is angle, not like considered like this. Not like this. You can write the problem, but it is angle. So among this, arrange the following according to their increasing boiling point. So this should be the sign. The highest is for pentanol. Pendant 1 or. Behind that, just behind that will be pentanal, that is aldehyde. Aldehyde will be smaller, like CH3, CO. Oxygen is more electronegative, so pulling this electron density there. Or you can write here minus, like this also you can write the proton. It is polar. It is polar. So this is pentene. Just behind that ethoxy that is slightly polar. That is slightly polar. So here in this way. Then you can write a complete positive and complete negative. But behind that, that is ethoxy-ethane. Pentanal, then ethoxy-ethane, slightly polar. Pentanol, this is H bonding. H bonding. This is polar. Then slightly polar. Slightly polar. And behind this, is what normal butane and butane. And butane. That is non-polar. So hydrogen bonding. Hydrogen bonding, polar, slightly polar, and non-polar. That's about the boiling points. When you consider the atomic masses of these different compounds, then higher mass will be having higher boiling point because of its heaviness. Otherwise, these things are very important. The force of interaction or the force of attraction between the particles. What about the solubility of alcohol? What about the solubility of alcohol? Solubility, is it soluble in water? Of course, alcohols are soluble in water in any proportion. You can mix any amount of alcohol to water. It will be mixing in any proportion due to the formation of hydrogen bonds between alcohol and water molecules. Formation of hydrogen bonds between alcohol and water molecules. So they are soluble in any proportion. Next, we are moving to the chemical reactions, chemical properties of alcohol. First chemical property is alcohols can act as acid. Alcohols can act as acid. In what way alcohols can act as acid? We'll be learning many chemical properties of alcohols. They can act as acid. They can act as Bronsted acids. Bronsted acid is giving it. But there should be another species to accept that H+. What is Arrhenius acid? Giving H+. What is Arrhenius base? Giving OH minus. So alcohols can act as acids. Alcohols can act as Bronsted acids. Alcohols can act as nucleophiles. What is a nucleophile? Like this, alcohols can act as nucleophile. Alcohol can act as acid. Alcohol can act as Bronsted acids. Bronsted acids. So there should be a species which is capable of accepting that protein. Accepting that protein. Can be H+. Oxide is one electronegative oxide that pulls the electron pair towards it, and X can go without any electrons. It can means H can go as H+. So B minus can accept that H+. B minus can accept that H+. So this can act as bronze-stirred acid. Now, alcohols can act as nucleophiles. Nucleophiles. How? Nucleophile. Nucleophile either it should have a negative charge or it should have enough electrons. It should be having it should be an electron-rich species. So here, of course, you see the nucleophiles is to an electrophilic sender. For example, this is an electrophile. It can make a bond with their nucleus. So alcohols can act as nucleophiles. Then what? Alcohols can undergo oxidation. Oxidation. Yesterday we said alcohol on oxidation gives aldehyde. On aldehyde on further oxidation gives carboxylic acid. Anyway, alcohols can undergo oxidation. Alcohol can undergo strong oxidation to form carboxylic acid using which strong oxidizing agent? Anybody can say strong oxidizing agent?
MnO4.
Alcohol can be oxidized to carboxylic acid by using that potassium permanganate is a good oxidizing agent. So alcohol can undergo oxidation. You see this H. Oxidation means addition of oxygen, that is oxidation, or removal of hydrogen. Here we will be learning in terms of removal of hydrogen. H and H will go as H2. What is remaining? HCH2. That is HCH2. HCHO. What is remaining? That much is remaining. Hydrogen is removed. So here alcohol can undergo oxidation. Oxidation. That is another chemical property of alcohol. Then what? Protonated alcohol can act as an electrophile. What is meant by that? Protonated alcohol. Protonated alcohol. What is protonated alcohol? So R O H. Yes, this is alcohol. Protonated alcohol means when proton is put on this protonation. Can alcohol be protonated? Yes. Alcohol can use one pair of electron, make a bond. This pair of electron can be utilized to make a bond with one H plus. H plus के पास कुछ भी नहीं. H plus no electron. H plus doesn't have any electron. So to make a bond with H plus, the other species should bring a pair of electron. Of course, if oxygen is having a pair of electron, oxygen will be utilizing that pair of electron to form a bond with H. So it is losing, so I am putting a positive charge over there. Now what happens? I said this protonated alcohol can act as an electrophile. So now you see the possibility of removal of water if this positive charge is cancelled by taking this pair of electron, then the CH3 electron, CH3, H. So carbon will be using. So what is coming from there? That is CH plus. Electrophile. So protonated alcohol, see after the water molecule, can act as electrophile. So I'm writing here number 5, protonated alcohol can act as electrophile. Protonated alcohol can act as electrophile. Now, alkoxide ion, which can be formed from this alcohol. What is alkoxide? That is, for example, from this RO minus. That is alkoxide. RO minus. RO minus. You cannot exactly take the reaction of alcohol because here it is alkoxide ion, not exactly alcohol. Alkoxide ion. How do we get alkoxide? After the removal of this H plus. What is remaining? This pair of electrons will be remaining 4. H plus 1, H plus will be taken by this Bronsted base. Bronsted base. Bronsted base can accept H plus. Last year we learned Arrhenius acid, Arrhenius base, Bronsted acid, Bronsted base. Arrhenius acid means which can give H plus ion, Arrhenius base means which can accept, which can give OH minus ion. Bronsted acid means which can give H plus ion to a species which can accept that H plus ion, and that species will be accepting that H plus ion. The other species will be accepting that H plus ion. So Bronsted acid means which can donate a H plus ion. Bronsted means which can accept that H plus. So here, this cannot produce OH minus ion. This is not Arrhenius base, but it is Bronsted base. This is Bronsted base because it can accept H plus ion. See, this cannot give OH minus ion. No OH minus ion. This is not an Arrhenius base, but it is Bronsted base. Suppose this has taken that H plus ion. What is remaining? RO minus. H plus is taken by this H plus. So here it is cancelled. BH. So what is remaining? This pair of electron is remaining here. So I am putting here and that minus charge. That minus. So this is what alkoxide ion. This is called alkoxide ion. So alkoxide ion can act as a Bronsted base. Now it can accept an H plus ion. It can accept an H plus ion. So it can, alkoxide ion can act as a Bronsted base. Bronsted base. So these are the reasons. Alkoxide ion is not properly alkoxide. We are learning under this category. Many reactions are there. That is alcohol can act as acid. Alcohol can act as Bronsted acid. Alkoxide ion can act as Bronsted base. Alkoxide ion can act as Bronsted base. Alcohol can act as Bronsted acid. Alcohols can act as nucleophiles. Yahan se it can do this reaction. Alcohols can undergo oxidation. Primary alcohol will undergo oxidation to form aldehyde. Secondary alcohol will undergo oxidation to form ketone. Then primary alcohol can undergo strong oxidation to give carboxylic acid using chemicals. Protonated alcohol can act as electrolyte. Protonated alcohol. That water will be removed. So these are the reactions, general reactions given by alcohols. We are going to one by one. First one, alcohols can act as. First one is alcohol can act as. So I am removing rest all. Now we will be dealing with this property, that is chemical property. How does alcohol act as? ROOH. अगर X नहीं है तो फिर a pair of electron है, one minus charge will also be. So, alcohol can act as acid base, which is the sign. You treat it with metallic sodium. As metal plus acid gives metal plus acid. Metal plus acid. Use metal for example sodium. put one piece of like this, one piece of sodium metal into alcohol taken in a test tube. Take alcohol, ethanol, or alcohol what you drink. Take alcohol in a test tube and put one piece of metallic sodium. Currently, you will see evolution of metal. That means alcohol can react with this metal with salt and iron. What is the salt form? Na plus minus it. The alkoxide ion is from sodium alkoxide. This is the salt. Salt and iron. Metal plus acid gives salt and hydrogen. So here, X plus is going, X plus is going, means X should go without any electron. X should go without any electron. For that, oxygen should take that pair of electron. Oxygen should pull that pair of electron. Oxygen should pull that pair of electron means anybody who can assist this process will increase the acidic nature of this alcohol. For example, CH3, alcohol. Suppose I am replacing one by chlorine. Chlorine can assist in pulling this pair of electron. So this will be a better acid than this. If I replace one chlorine, this chlorine will also be helping in pulling. You replace this hydrogen by chlorine. This chlorine will also be withdrawing electron density due to the electronegative nature of this chlorine. So such groups will assist or that will increase. Here X can go as very easily without any electron. This X should go without any electron. X should go without any electron. What all things are helping this process? Will be increased. So H should go without any electron. This electron pair will be pulled in this direction. If three chlorines are there, electron density is pulled in this way. All electron density is pulled in this way. H can go without any electron. That means H can go as H plus. This is far better acid than this one. You think opposite? CH3OH. It should go as H plus ion. Here, if I replace these three hydrogens by CH3, will these CH3 groups assist? What is the nature of CH3? Electron donating or electron withdrawing? CH3 is CH3 an electron donating group or electron withdrawing? CH3 is an electron donating group plus psi effect, or you can say hyperconjugate effect. That word hyperconjugate effect we won't use when we use inverted effect. So, through each plus psi effects, this will show plus psi effect, this will show plus psi effect, this will show plus psi effect. So they all will be pushing electron density. So here this electron density will be high. So this is a weaker acid than what I explained in the previous. Weaker acid acidic, but it is very weak because of electron donating nature of electron withdrawing groups will assist this process, while electron donating groups will decrease the reactivity of this or inhibit this electron. electron donating groups will inhibit. Electron withdrawing groups will enhance the alcohol can act as acid with metals, with aluminium. With the metals, they can release hydrogen gas. But these alcohols are not so strong acid like mineral acid like HCl, H2SO4. Okay, so it's acidic, that's all. Don't think that it is like H2SO4, HCl, or have burn. No, when it this cannot burn your skin and all. It's acidic, but not so acidic like the mineral acid. Can it release carbon dioxide with sodium carbonate? You know that metal plus acid gives salt and water. Carbonate plus acid gives salt plus carbon dioxide plus water. But alcohols are weak acid, they cannot react with such weak bases like sodium carbonate and sodium bicarbonate. So this alcohol cannot react with sodium carbonate and sodium bicarbonate. Then phenols. Phenols are acidic. Phenols are acidic. Phenols can also form salt and water. Again, phenols also cannot react with carbonate and bicarbonate to form carbon dioxide, salt, water, and carbon dioxide. Such reactions not there for phenol also. Phenols are better acids than alcohols. Still, phenols cannot react with sodium carbonate, sodium bicarbonate. Similarly, alcohols also cannot react with sodium carbonate, sodium bicarbonate. These are weak bases. With metallic sodium, it can be salt and water. With the sodium hydroxide, also they can react with sodium hydroxide. Alcohol will react with the sodium hydroxide to form salt and water. Salt and water, sodium phenoxide. Plus NaOH. Sodium phenoxide. Now we'll move to acidity of phenols. This is very important, acidity of phenols. Now we are going to the acid nature of phenol. You know that this carbon atom is sp2, carbon. sp2 has this carbon is more electronegative, so it will be pulling the electron density towards it. H electron density from that OH bond also can be withdrawn. Effect is there, so H can easily go as H plus due to the electron withdrawing nature of sp2 carbon. Phenols can easily leave that H plus. Not only that, after the removal of H plus, what is obtained is phenoxide ion. Phenoxide, H plus gone. What is remaining is phenoxide ion. Phenoxide ion is more stable than phenol. Phenoxide ion is more stable than phenol. So phenol immediately changes to phenoxide ion by releasing that H plus. So phenols are very good acids. Not so good like our middle acid HCl, H2SO4. Okay, phenols are acidic, but not so good acids like our normal mineral acids. How phenoxide ion is more stable? In phenoxide ions, you can write 5 resonance structures. In these 5 resonance structures, phenol you can write 5 resonance structure. Here also you can write 5 resonance structure, but this is more stable than that one because in phenol there is less charge separation, while in phenoxide ion there is less charge separation, while in phenol there is more charge separation. Less charge separation means stability. We will be seeing that in the next class. So phenol, after the release of H plus, it will be changed into phenoxidine. This phenoxidine is more stable than phenol due to less charge separation, while phenol there is, of course there are 5 rosine structures, but more charge separation is there. Thank you.